Thank you very much indeed for having me here. And I must say, first thing, that I haven't proposed the title, an inspirational talk, because I'm a little bit more humble than that. But I will give you a few examples of what I've experienced during a long period of observations in the field regarding field work in Svalbard, starting 1972 and still continuing. I'm a geocryologist, and I have been studying especially connection between climate and landforms, including also ecological dynamics in a tundra environment. I've been working on these areas, but we will today only focus on the first one, Svalbard. The reason for that I started up here was that up in Svalbard you have the longest climate records of the high Arctic environments that exist. And my supervisor said that go up there and see what you can find about the connection between the climate and some landform processes that he was interested in. I wasn't that very interested. Anyhow, up here we had this long record where we could see the effect of the warming after the Little Ice Age, and then a change of cooling climate during the 30s and up to the 60s. And then I ended up here in the 70s, just before we got this warming that we today call climate change. At that time, it was not at all discussed. So 1972, when I started my fieldwork for my dissertation. Anyhow, we see now that the annual mean temperature up here at Icefjord radio station, which I had as my base, has increased tremendously. And actually, it is the area, the local area, where the climate has increased the most all over the world. And that goes for the mean average temperature. It also goes for the summer temperature. And we have an increase from about 3.5 degrees in July up to over 6 degrees. And that's quite a change. That must, one way or the other, be visible in processes and whatever we investigate. So I had a very, very ambitious supervisor. He asked me to do all this baseline geomorphological mapping, etc., etc. We just go through it very quickly. So they'll see that was really a task that he put on my shoulders. So I ended up here in this area on the west coast of Svalbard, and I got Icefjord radio station as my base, where we could go back once a week to have a shower, get some free liquor, and then out again on the tents. And we chose, apart from, besides the long climatic record, we had a long history of research in this area, Svalbard, with records all back to the mid 1800s, with both Swedes, people from our university here in Lund, and elsewhere in Sweden, and also in international. That meant that we had also a possibility to go even further backwards, even further back than 1912, when the climatic record started. And a lot of other interesting factors that made it easier or relevant to study this area. So I started at Icefjord Radio August 1972, and has continued, still working. This is on August 2019, where we took the last year's readings. And a little bit of showing how I think and how the problems has been during this period. Say, for example, this stone. It has been lying on this beach ridge where we are for 8,200 years. I haven't been studying it that long, but it caught my eyes in 2010. And 2 years later, it looks like this. So, and what has happened? So for 8,200 years, the thermal massage has done nothing to this stone, or it made it ripe so that in 2012 it just ruptured. Or something might have happened, a change in masseurs, masseurs with harder hands could have started and the stone broke. Is this something negative or is that something good? Well, this stone is interesting for some people. The rupture and disintegration here might be of a negative thing for others. But what is happening is that it's fracturing into smaller and smaller pieces and will form soil. And that soil, vegetation can enter and grow in. A stone as such is interesting for anyone, more than it was a very nice stone, isn't this? Anyhow, so studying this process, I should have started 8,200 years and continued every year to see what was going on up till it cracked and fractured. The same, I actually tried to follow what was going on when it came to a combination of chemical and physical weathering on this dolomite limestone. We choose a number of investigation surfaces, approximately 1.5 square meter large, and we try to follow them each year, how much matter or fractions were produced every year. And a little bit happened, but after 22 years, we could not find any correlation whatsoever with climate. So we gave up. But then, after another year, a couple of years, suddenly a big slab, you see the blue arrow here, just broke loss. It was outside the investigation plot, so it was a new use to our records. We couldn't use it anyhow, but it was interesting. But it gives you an idea how 3-year projects of how worthless they may be. So, going back to history, 1972 to 2009, you see a lot of things change. Numerous changes were observed. Many of them were connected to climate. But what about damages and losses? I haven't been looking at it in these terms. I might be using the completely wrong terminology here in this context. But let's see. I would just take some examples. Change number 1, sea ice. As this station is situated along the coast, we also had a task to map what was going on along the coastline. So it was coastal geomorphology. So when I started up there in the Gullardales, you met the pack ice already a couple of hours north of Norway. And then when you come up to Svalbard, the west coast was completely covered with sea ice, and the fjords were completely packed with ice, like this. So getting ashore was a hassle, a damn hassle for normal people. Not for this guy who went out in his Gucci slippers and moved the ice flows away so that we could get ashore. But then in the, say, mid-80s, suddenly we got a change. No more sea ice along the west coast. All the fjords were sea ice, like any other typical Norwegian fjords, which are ice-free all the year round. And that meant something for the coastal geomorphology. So within this 50 kilometers large investigation area, I had a number of rivers that entered the sea. And all these rivers that entered the sea as any proper river should do. But then suddenly, starting in the, yes, as I said, mid-80s, beginning of the 90s, started to get blocked by huge beach ridges being formed during the winter because there was no ice breaking the waves. So the big beach ridges were formed. And that continued year by year. And some of the rivers changed their outlet and their stream pattern. But the most important thing that happened was that during snowmelt, all the wetlands inland from the shore got flooded. And that meant that the active layer got deeper, and we got a methane emission from the area. But that has not, I have not studied that at all. But we studied the flow in the rivers. You have in the upper graph, you have the normal flow of the river, and then in the lower you have the new flow. Nothing, and then flush out with all the water in 2 or 3 days. And as we should have something fun to do, apart from all the geomorphology, we also study the bird life in the area. So we checked the wetland birds breeding within the catchment area there. You have the species here. And we saw that this flooding and the flush flow in the rivers took place during the most critical period of these birds' breeding period. And during a flooding years, between 20 and 100% of the nests were destroyed. So almost, if you take an average, more than 50% of the species breeding within this catchment area, they failed with their breeding. And I then constructed this sequence of event: changing climate, warmer climate in the Arctic, less sea ice, unprotected shores during the winter storms, higher and cemented storm ridges, blocked river outlets, rising rivers and lake levels and flooding, inundated bogs near the lakes and the ponds, animals, drainage patterns, and breeding and flowering failures in the catchment. So this is a very simple, straightforward sequence, but from the global to the individual. And then the loss of sea ice meant that these guys could enter the fjords, and we could get an increased tourism. So, and every one of these big ships bring 3,000 to 5,000 tourists ashore. And as long as I get ashore in Longyearbyen, the main city up there, the tourism thrives and the business is going very well. But we know that there are problems involved. For example, this ship, perhaps you recognize it. It travels so very close to the shore here, just outside Kaplinge, that no fishing trawler or our rubber boats would go that close to the shore. And this is the one, huh? The same ship, 2 weeks later. No, this was not on Svalbard, as you know. It was down in the Mediterranean. But the problems are the same. If it happens up there, it will be a hell of a problem. There are alternatives, of course. Very nice such alternatives. But never the same, there are 30,000 tourists a year coming to Svalbard. And they do leave footprints. Not big as dinosaur footprints. This is, of course, not the dinosaur footprints. But this is. They are within my investigation area. It's a dinosaur like this one, Icanogon. And it's positioned in this rock wall here, or it was. But it is lost forever. It's gone. The Norwegians blame the Russians up there that they have been taking it away, stealing it. But it could be a natural process, who knows. But it's more fun in this context to say that they were stolen by Russian tourists. We have another thing that connects to this. The polar poppy that we have up here. In 1924, in a report, this flower was only found around Kaplinge at one place. In 1974, we found it on 10 places. 94, I had 2 girls making their masters, and they found it like this. And in 2014, we had a doctor's course up here. They found it like this. And you see the pattern. It all focus on the radio station, which now is a hotel. So it's the footprints that has helped this flower to spread. And today it looks like this. It's spread all over. It's not an invasive. It's a native flower that makes probably no damage, or it makes no loss, but we don't know if it is a loss or a damage yet. But something is happening at the least. Also, the ice, the changes in sea ice, makes more polar bears to get ashore, and they are very hungry and dirty. That means that when we're having courses up there and doing field work, we need to be aware. But according to research on polar bears, the polar bear population is only locally disturbed. Most of the polar bears, they will adjust sooner or later to the new situation. That is at least what they say. In this context, we also have winners. And the whales have come back. They were completely gone, almost all the whales, even the big whales. I didn't have any good pictures of them, so I've taken myself. The white whales has always been there, but there are more now. But also all the big whales are back in the fjords, hundreds of them. And the walrus is coming back. It's also all over. So there are winners and losers. Change number 2, winter precipitation. It has increased tremendously. And both when it comes to snow precipitation, that causes trouble in Longyearbyen, not within my investigation there. So I will only summarize that you have damages and losses, both on properties, and we have death. That depends on the increased winter precipitation. The winter precipitation is also important to the Svalbard reindeer. These are very tough creatures. They are used to sustain the winter because they eat themselves fat during the summer, and then there are no problems for them to live on the dry grass during winter time, if you don't get winter rains. But that we get very much more frequently now. So all areas are getting glazed by ice. So the reindeers, they suffer. And we did some simple investigation that we could see that the populations within an area dropped very, very clearly after winter rains. That means that it is a damage to the reindeer population, but so far it's not a big problem and not a loss. But it is another problem for the reindeer, who has a lot of problems up there. It's a plus for the polar bear, get an alternative to the manure ashore. We have another guy, the muskox. They're already extinct. A big mammal like this, extinct. The last one died already in 1982, so it's difficult to say whether we have a really connection to climate change or not. Anyhow, 72 and 75, we had them as pets around the station and during my field work. But their population went down, and in 82, the last one, as I said, died. And that is definitely a severe loss. Change number 3, permafrost and active layer. You know that you have a huge distribution of permafrost all the northern hemisphere, 50% of the land surface approximately. And the active layer is a very simple and very straightforward thing to investigate. Let me see. Oh, how do you do it? Come on. Anyhow, with the probe, you're just taking the depth of how much is thawing have been thawed during the summer. And here we are digging ourselves down to it. The active layer is the thawed layer above, and here we have the permafrost table, the yellow dotted line here. And the depth of this active layer is a measure of all energy has come in during the summer. So if you can follow that year by year, you will get a very good measure of what's going on. And we have a number of sites where we've been following the active layer in 100 meter by 100 meter squares. And here you have a summary of the measurements from 72 to this year. You have the yellow dots are the summer climate, and the red bars are the depths of the active layer. So in the box where this measurement are from, we had initially 15 to 22 plant species on every square 10 meters, and the surface was a sink for carbon dioxide. But from now, when you have got a very deep active layer, you will get a lot of water standing and a lot of turbulence, cryoturbation, and you have got to change into 2-3 species per 10 meter, and we get a clear carbon dioxide and methane source emitted to the atmosphere. Colleagues of mine are measuring this and will get more accurate data on that. You can follow it. So this is definitely a damage and a loss for the globe, because huge areas have deepening active layers with increased emissions of these greenhouse gases. Another thing that is connected to the deepening active layer is that lakes disappear at the end of summer. They didn't before. So lakes that look like this, very shallow lakes, but still, with the deepening active layer, they are getting completely drained in September. And that is, of course, not a big deal, but the bottom of these lakes is very, very rich on organic matter. And that organic matter contains all goodies that are being released as both phytoplankton and zooplankton during the spring period, when all the young chicks are coming to these water bodies to have their first 2 weeks of food. Now they're gone. We have other changes. Change number 4, changes to ISO radio. That radio station was the communication center between Norway and Svalbard in the old days. Gradually it has been automatized, so now there is a cable from Norway connecting directly to the Longyearbyen center. And that meant that the good old days with a crew that stayed there 9 months without any supply whatsoever, because there was no connection with ship during winter time. All these good parties that we had, they're all gone. And now when we come up there, now it has been turned into a hotel. So what was before a radio station with 7 guys, it's now a hotel. And that has been the reason for this station surviving. So it's now a possibility for people to come there and to learn about this very nice environment. So in this sitting room here is now dining room. So this is a damage or loss. Yeah, you can joke a little bit. And it's just to be old and just time to enjoy and the service and the comfort that the station now offers. But apart from that, the area still have all the very nice surroundings with not so many footprints. And there's so much more to do and to connect to the studies that we have been doing for so long time. So thanks for listening. Hope to see you up there.
Before we break for lunch, a well-deserved lunch, I think. Any questions from the ecologists amongst us? Let you think for a minute. Thank you for a fascinating talk.
Thank you. Thank you.
I was wondering how it feels going up to Svalbard now with these changes that you see from a scientific perspective, but also as a person who's been living there or being there over the last 40 years.
it's of course with very, very mixed feelings. But the possibility to run courses up there now with this very nice infrastructure that has been developed is absolutely something that I really love. To be able to help in transferring the knowledge and introducing new students to this area and to these problems. So mixed feelings, but I'm very happy, and I'm very happy with the comfort that is up there now.
Thank you very much for that. Me working with agriculture, these are very highly anthropogenically affected areas, or I can imagine also urban areas. It's a similar problem, whereas this is pretty natural, not so anthropogenically affected, at least not locally. So would you recommend to set up monitoring sites that can help the global community inform on quick and slow changes? Because these kind of long track records are so valuable. But how do we do it, and who should maybe support that kind of monitoring for the benefit of a global good?
The first thing is to see to that the Norwegian Meteorological Institute can continue to have their automatic station running at least. And then we have the university studies in Svalbard, UNIS. They are running projects out there, following in my footsteps, so to say. They're doing modern measurements of permafrost temperature down to 7 meters depth. With modern loggers, etc. So they have very good connections to what we are doing with these very simple things. And the active layer measurements that we started that very early, they are within a Northern Hemisphere network called something. Administrated by the International Permafrost Association. So we have our data in that system. And the UNIS people or researchers, they have also their areas where they monitor with the same method inside Longyearbyen. And there is also measurements in Jonas and the other center for research up in Svalbard. So I think that, and together with UNIS and together with Norwegian Polar Institute, together with the Norwegian government, who are very, very keen on keeping research going on and to have their flag flying up there, I think that there is all the best already in place to keep things going.
Yeah, we have a question from Richard in the audience.
Thank you. Just on the ecology perspective, since we're asking about that. The winners and losers that you mentioned, this seems to be a dominant theme in ecological research in general. Yeah. There's species turnover as some species become maladapted and some more adapted to their local conditions. But there's also an argument that some of the winners that we see, this is more to do with species interactions, and that so in the case of predators, they benefit from the maladaptation of the prey. So some of your predators there with the caribou. The danger of that is we could be a little bit less worried that this is just a natural process. Some win, some lose, but some of the winners that we're seeing, maybe this is just a temporary win, and that the system's in flux. And what we're looking at here is they benefit in the short term only to find themselves come unstuck in the long term. What is your feeling from your perspective on Svalbard?
My feeling from the area that we have been studying a little bit is that some of the wetland birds has been temporarily, I think, because there are other areas where they very easily can move. So I would think that they will learn, or their next generations, they will find better solutions for finding their place to put their nest at the early. But the problem is that you don't see the problem until it's too late. So, and the real losers that we have seen, that's the eider duck. That normally before the change from the radio station to a hotel is we had about 80 pairs nesting around the station. This year we had 0. And that is probably partly by disturbance, partly by the chicks that don't have these small water ponds to go to when they're hatching, and to stay there for a week or two before they go out into the sea. And partly also that the guys who before stayed at the station that didn't care damn about laws and regulations. So they shot the polar bear, no, not polar bear, the polar fox. Whenever the polar fox came to steal eggs, they shot him. And when the skua came to steal eggs, they were shot. And when the big polar glaucous gull came, they were shot. Today, they're protected. Nobody dare to scare them. And that also affects. And that's a part of the dynamic, I would say. So there are winners, there are losers. And being a geomorphologist, I have only studied some of the flowers and some of the birds, etc., as something that do besides every other thing. So I'm not a specialist in it at all.
One more question, and then one question at the front.
I was just wondering whether you felt the pace of change that you've been witnessing is quicker or slower than has been predicted from models, both geophysical and biological. And if you feel that it's more rapid, why would you think that's the case?
So the trend, if you only take one example, you say the active layer, it has followed the summer temperature or the annual temperature, whatever you compare it with, very, very well. And it has gone down deeper and deeper and deeper, but then it has been leveled out. So now, even if you have a colder summer or a warmer summer, you don't see any change anymore because they were now so deep down. So there is some kind of balance. But the problem is that when you have passed in the wetland areas, where you pass the peat layer and get into the mineral soil, you will start to get cryotubation. That means that the peat are mixed into the mineral soil, and the peat is being oxidized, and you will get carbon dioxide from it. And that is the main thing, that you will get a complete change of the land surface from a vegetated area with a turf isolating cover now to a mineral soil area with pattern ground formation. Was that an answer?
One more question, I think, from Leonard.
Okay, another profound change, which I would like you to hear your comment on. About 15 years ago, Spencer Wert wrote the book, The Discovery of Climate Change. And there he said that before climate change became a popular topic, climatology was so boring that the only place you could find it was in the attic of a geography department. I suppose it has changed. And to what extent sort of has the geographers been able to keep up with this?
Because they changed over to with modern equipment to study the greenhouse gases. So I would say that other departments are to 75% are dealing with greenhouse gases and monitoring greenhouse gases in various environments, including Svalbard. But people like me studying what's going on the ground with the fauna or the flora are very, very scarce.
Yeah.
So we are more or less instinct as well.
Yeah.
Soon.
Thank you, Jonas.